So on that note, I would like to thank everyone who is joining our August session for the Silicon Valley IEEE Consumer Technology Society. And as always, for our agenda, allow me to do the introduction of the goals and objectives of the IEEE Consumer Technology Silicon Valley Society. So for the agenda today, we have an introduction and overview from yours truly, and then we will be doing an introduction of Bryan Cheng and the Globalscale Atmosic M2 BLE module. And then of course, we'll have a little bit of time left for the QA and networking. So during this meeting, I would encourage you highly, if you have Twitter accounts, Facebook accounts, or anything, please post. The promotion of it, IEEE, especially in this difficult time, is very critical. And what the presenters like Bryan are doing, they're bringing technology to the forefront and also giving us the perspectives. The 2020 officers and volunteers are Olga is your truly chair, Dev is our co-chair, Avid is the vice chair, Pat Vasank is our secretary and treasurer, Michael Wang is our marketing chair, Joseph is a webmaster, and Palak is a marketing co-chair. We are always seeking volunteers and officers, so if you are having a desire to help, please join the group. Our officers serve period is 1 year, and after that there is another election, so there is always a probability for promotions. We are also always looking for new speakers, programs, events, and any ideas you might have, so please bring it forward. Our next society meeting we will announce shortly. It will be at the end, probably the 4th week of September. And with NXP, we were hoping to do it on site, but with the Delta virus spinning off, most likely it will be again virtual, so I apologize for that. And in order to become an IEEE member, this is our membership fees. You get a discount, and then when you join Consumer Technology Society, you get also a lot of benefits, including the magazine subscriptions, access to events. This is the magazines which you have. And on that topic, I'd like to introduce to you today's speaker, Bryan Cheng, who is an amazing individual. He's VP of Sales and Marketing for Globalscale Technologies Incorporation. He has over 10 years experience in this field. Bryan is very experienced in product development and sales, and developed a lot of open source platforms like Shiva Plugin, Espresso, and won a lot of design awards. And we just talked with Bryan, and he is also a professor and teaching at the University of California, Santa Cruz. The topic of today's talk will be the power in your home using cell battery power and how batteries are changing the paradigm of the electric market grid. So Globalscale is a Atmosic M2 BLE module, is an ultra low power module which enables new generation of ultra low power applications in the IoT and connected space. Not only that, but it also unlocks a new market of connected homes. Convenience previously unachievable with other low power devices that require batteries or rechargeable devices. And we will also go into some amount of technical details on improvements in RF and power states that especially compares to low traditional power vendors on our instruction set. We will list out some typical applications of which there are reference designs such as batteryless keyboards, switches, PV cells, power locations, asset trackers. We will delve into at least one case study in either consumer tracking or safety tags. So basically, green technology is taking over our market. This is a $1 trillion industry, which is up and coming. And we are on the company is showing such as Globalscale, showing a lot of innovation and forefront thinking. On that note, allow me to bring to the stage Bryan Cheng, and I will stop our sharing. Bryan, the floor is yours.
All right, thank you. Are you able to hear me okay?
Yes.
All right, let me go bring the screen share right now. Thank you for the introduction, Olga. All right, so yeah, so I think have you seen my PDF presentation?
Yes, Bryan, can you make it as a full screen? There is a feature. Full screen mode.
How about now?
Yeah, perfect.
Yeah.
Thank you.
Yeah, so this presentation we'll talk about consumer products with energy harvesting and our ultra low power BLE module. You know, I make this very informal, so if you guys have any questions or feel free to jump in anytime. So for the overview, I'll go have a brief company and personal background. I don't want to make this too corporate, right? But I'll do some background so you know who I am and where we're coming from. And then we'll introduce two products, our M2 module, and then our harvesting system, which is based upon a more advanced Bluetooth chipset. We'll go over some of the technical advancements that allow this type of technology, as well as some of the energy harvesting features. So, low power Bluetooth is one thing, but being able to harvest power from solar, thermal, kinetic motion, these are also pretty important to this product. So we'll go over some applications in the IoT space, as well as some actual case studies. This is a new product, so there's not too many that we can openly discuss, but I'll give some case examples so you guys get a feel of what it's like. So just some personal background. I was a mechanical engineer by trade through the University of California system, as well as some liberal arts background. And my master's was here in Southern California. About 15 years total now in engineering, product development, as well as general management for all of this in embedded engineering and manufacturing. So Globalscale, we're actually an ODM, so basically design and manufacturing processes. We specialize in the IoT, wireless, and networking space. The company background was as a manufacturer, but starting in 2008, we started doing a lot of design services. Almost all of it is in the Linux and RTOS environment. So that's kind of the background of the company. I'm here in Southern California, about 20 minutes from Disneyland, if you guys know that area. So yeah. In terms of our partnerships, so we work with the big semiconductors, NXP, Marvell, OmniVision, which is an image sensor company, as well as memory company ISSI. And what we'll be talking about primarily today is Atmosic, which is a Bluetooth company, a fabless semiconductor, more in the startup stage. So a lot more, cutting edge technology. Yeah. So some background here. So Bluetooth and consumer goods. So I think, a lot of you guys probably have some work before in the medical or Bluetooth tracking fields. Bluetooth, I think, has become very commonplace compared to 10 years ago with the advent of smartphones. So kind of example here is in Japan, here is a RC toy. It was, primarily use sub-gig RF, but here nowadays, even because the smartphones are so common, we have Bluetooth enabled toys, as well as Bluetooth in other consumer medical goods. So just some quick background. So our Bluetooth module here, it's about 3 to 5 times more power efficient than typical Bluetooth 5.0 modules. So here's an example where we have, I'll show you guys real quick. Our module is pretty straightforward, Bluetooth 5.0 with a modem and front end, and as well as standard peripherals. One of the main advancements here is now with energy harvesting. So here's an example of our Bluetooth module as a PV cell tracker. So if you see on the right-hand side, you have your very standard, compute, Bluetooth memory blocks, as well as your peripheral I/O. So this is your I2C, SPI interfaces, memory, and sensors. And how it's we've kind of grown from other NXP, Dialog, Nordic Bluetooth is we've added these RF harvesting technology. So basically, we're able to harvest energy from RF in the environment. So this could be Bluetooth itself, Wi-Fi, or sub-6 signals. And from there, the power is sent to the onboard power management unit to power the actual devices. That's your harvest one in. And then it's not only do we have it through harvesting, but we also have harvest out, which enables energy harvesting through PV cells and thermal harvesting. So here, with this power management, we're able to store these power either through onboard batteries or capacitors, supercapacitors typically. We've also come up with 3 types of energy storage configurations here. So we have what we call battery-free, extended battery life, and forever battery applications. So kind of example here is for the battery-free, we have onboard basically a storage capacitor. So these are here on the top left, you'll see a PV cell. So these are applications where you have enough power, commonplace, basically from Wi-Fi or from solar, that you don't need to actually have a rechargeable battery or any advanced batteries. So it's good for environments where we have common light source and a lot of power here. So this is what we call battery-free. An example of that is our power harvesting, human interface device like mice and keyboards, as well as tags. And then the other energy configuration we also implement is what we call extended battery life. So here you'll have probably you don't have enough power to consistently charge this device. So here not only do we have a supercapacitor, but also a standard battery. So this could be a coin battery or something that can power the device when there's not enough power for a steady state or power on sequences. And then the other configuration is what we call forever battery. So this one will also have energy harvesting as well as a rechargeable battery. So like a lithium ion, lithium polymer typical implementation. All right, and then as an example of the RF cell harvesting, here's kind of a power graph showing how much power can be harvested from a couple of common sources. Here, 915 megahertz radio, as well as the 2.4 gigahertz Bluetooth or Wi-Fi radio. And from here, you can see received power in dBm as a function of distance between the device and the actual source. And then, as I mentioned, some common applications of this is asset tracking tags, security badges, and then keyboard and mouse, which are able to run just off of RF harvesting without any, any other external type of power harvesting. So one of the most common power PV is energy harvesting is photovoltaic cell harvesting. So here we use amorphous silicon PV cells. So basically like almost like a solar power device. We can use it with indoor and outdoor lighting. And from there, we can able to power a whole family of devices just from light. Also kind of example of how much power. So here we have about, this is a experiment with a 320 lumens PV cell. And we're able to get voltage as a function of milliwatts. So you can see how much power you can actually harvest from a very common indoor lighting scenario. The main applications here also are common, like asset tracking, as well as weather station, indoor, outdoor sensors. So you'll see, typical consumer weather stations, what you would see at a Costco or a retail environment. And we're able to power these, lightning sensors, rain sensors, just from a PV cell. And this is a good application where before they were all using, AA, AAA batteries that had to be replaced every 6 months, every 2 years at best. And now we're able to run them continuously with PV cells. And then here's an example of our beacon. This is our indoor reference design with 200 lumens PV cell. And then here we have the ability to track very much like a tile device. But here you have options for coin battery, accelerometer, temperature, humidity sensor. So this opens up a lot of devices, not only beacons, but also sensors such as CO2 sensors, PM 2.5 sensors. You can see here the block for our PV beacon design. So we have a both PV cell here on harvest out, as well as storage with a capacitor and coin battery. Another good example is thermal harvesting. So here you don't typically have enough voltage, so we add a mercury buck boost converter to get enough voltage for minimum 1.1 volt to power this device. So a good example of here's the power as a function of thermal delta. So you need typically at least 20 degrees C thermal difference to get enough power to power the device. So good examples of this is body sensors, thermal sensors using the body heat, as well as instrumentation for industrial environments where we have always have a good amount of heat that you can harvest. And then another type of energy harvesting that we're working on as well is mechanical harvesting. So basically from a switch, you are able to get enough power to also power the Bluetooth device. Basically the positive pulse from depressing, and then a negative pulse from releasing a switch. You can basically get 0.3 joules out of this device. So some good applications of this, which we're working on right now, is garage and access remotes in the smart home. So we work with a lot of OEMs such as garage door openers, and these are also have been wired or working with AA, AAA batteries. So now we're able to run these things perpetually or until the device fails, just with energy harvesting, typically with a switch. So an example of this is, I would say like a remote control where you always have a switch button as well as a access panel. Let's say for a garage door opener, you have a keypad, and then just the act of opening the lock and a single press is enough to connect Bluetooth from our smart home garage door opener to a keypad. So mechanical harvesting is a good impact. And then the impacts on the consumer technology. So, you know, this long-lasting forever battery, it really, I think, saves a lot of waste. Whereas we had trackers, actually animal pallet trackers and trackers that go on livestock. So these typically we had been working with, you know, Sigfox, LoRa, and these typically would last around 6 months to 2 years, and they had to be replaced. And nowadays, with this type of technology, we're able to keep this product, you know, continuously operating until the pallet fails or the livestock is harvested. So it's a lot of good opportunity and improvement in our society here. So also, we're opening some new opportunities in the IoT space. So we'll go over some of these examples here. So here's our PV beacon again with sensors and as well as some blockchain-based encryption that we've placed on this Bluetooth microcontroller. We've also worked and implemented display technology. So here we have a Bluetooth energy harvesting with e-ink. So that could be a display for a supermarket or even like a tablet device. So this also enables this type of product to run without power, constant power, or replacing batteries. Another example of this is the medical field. It's somewhat consumer oriented, but this is a customer in the Bay Area where they use air puffs to relieve migraine in the ear canals. And now with this Bluetooth, we were able to significantly reduce the size of battery needed to run these motors. So another common example for the medical area. So this one's going through the FDA process right now. So probably in another year, you'll probably see this with energy harvesting. And then tracking is a big thing, right? So this is TraceSafe, which is a contact tracing device. So it's very common in, I would say, in some parts of Asia where you're required to have contact tracing and tracing of the individuals before they're you know, after travel. So it's a good example where you can run the device without charging for a couple of weeks. All right, and those are just some examples of the Bluetooth with energy harvesting. So thank you so much for the time, and let me know if you have any questions.
Brian, we have a question.
Okay.
Go ahead. Everyone is on, you can unmute yourself and ask question when you need it.
Okay.
There was a question, guys, in the audience. Daniel.
Oh, okay. Sorry, I pressed the wrong button here. I was a little puzzled by your remark that Bluetooth somehow reduces the size of motors needed to put air puffs in people's ears. Can you please clarify that?
Sure. No, so like this is the example. You know, you know, the motor is still the same size, right, to run the puff, right? But that's just an example of where we've designed in this ultra low power Bluetooth, right? So with energy harvesting, we're able to, let's say, increase the amount of battery available and reduce the consumption. So that is that so basically this product, this era medical product that they were using an older Bluetooth, and we replaced it with this ones, so we can increase basically battery life on that application. So
Okay,
and
so what you're saying is that the radio takes less power, and therefore it's more convenient to use. Okay, thank you. That makes a little bit more sense to me.
Yeah, yeah. If we could get run a motor, that would be quite impressive, but we're not yet.
Well, if you have a really big switch, that should work fine.
That's true.
Okay, thank you.
Okay.
Jim, you have a question? Okay. Jim, Mike, go ahead.
Yeah. One of the things that's important in our application is very low standby energy consumption in the Bluetooth module. You didn't talk too much about M3 and technical details, but how low can you get the standby energy to be?
Oh, yeah, yeah. I didn't go too much into like the the typical like standby power, wake power, but I don't have it here, but I can send you some if you don't mind. Send me an email. I can send you kind of the techno. I focus mostly on the energy harvesting here, but the standby power and then the wake power, I can give you some figures if that's what you're looking for.
Okay, super. Thank you.
Sorry about that. Yeah. Yeah, if you can send I'll share my email address here as well too, and then we can I can give you some better data figures on that. So
yeah, that would be great. And the slide will be also shared and uploaded to the IEEE website.
Okay, great.
Including video. And Chris, Sri, you have a question? Sri Murthy. Sri Murthy, you have a question? You can talk. Okay, I guess no question. Okay, let's move on.
Okay, yeah. So that's all I have. Thank you, Olga. So.
Okay, there is a question from Michael. Is there a reference design of PV beacon that we can experiment with?
Yeah. We have a reference design that can be with a full software SDK package and stuff. So yeah, I can provide reference designs for just the module itself or with the PV beacon. So no problem, I can provide that. If
and are they all ARM-based designs?
Oh yeah, these are all ARM-based. These are an M0s and the next one will be an M1. So these are all microcontroller ARM designs.
So how do we get the access to the reference designs?
Okay, I actually sell these reference designs. I can send a link from our company where we actually sell these online. So it's no problem. I can provide.
And another question is, you mentioned that this design, which is EI-Link displays, how big is the display?
I actually only have one that's I think it was I think I had like about 3, like let's say about 40. The one I have is 40 millimeter by 40. So but we can get larger ones and stuff as well. I think 40 by 40 was the reference I had.
Shri has a question about the different designs and configurations. What type of configurations? Do you have like a summary of the configurations and MTBF?
Oh, the mean time before failure?
Mm-hmm.
Okay. I actually don't have the MTBF yet on these devices, right? So there's a couple ways to do it. One is through simulation, and one is through calculation, right? So I think we have one product. I think we've done about 50,000 hours in continuous use, but probably we can go more than that. That was just what we tested. Oh, I think I see the question here on the questions on
chat, right?
perform. So at least 50,000 hours. We probably can do more than that. But, that's what we've tested. You know, that's about, I would say, almost some 4 years, around 4 years of continuous operation. What's included in the SDK? What compilers? IAR workbench, debugging. So yeah, there's we have full SDK. So we can, yeah, there's a tool chain, full tool chain design. There's also an AT command set as well. If you want to connect this thing, you know, quickly with another host, so I can provide some details there as well.
How did you arrive at your numbers?
Yeah, so we just run, those were basically with the simulation, right? So we ran, you know, we go through a lab actually. We have them test to a certain number, 50,000. So we run it in a chamber, and can we? Okay, so basically we just tested to that, and we made sure we actually can pass to 50,000.
The recording will be available right after this, and then we have a webmaster who will upload it to the website. If anyone interested before that, please send me an email and I'll share the Zoom link with you.
Okay, I will send some also some links to the software. I think there's some questions here.
Right. So do you have it in an open source? Because it seems like an open source platform. So that means you have a GitHub?
I do have a GitHub repository. This one, since it's new, I haven't posted it publicly there yet, but I do have a just basically on the website where I have an open source version of the SDK, which can be taken publicly. So there is some stuff that's not yet open source, but at least the Bluetooth configuration, the AT command set, those are all open source. So I can provide that here as well. Send at Delta Max Tech.
Yeah, we'll send it over.
Okay.
Very cool. Okay. So my next question is, you mentioned about the Shri is asking of thermal energy harvesting and also makes of the failures dominant.
Correct. Yeah, thermal energy. There's always a lot more. I guess like every time there's
sensors, right?
Yeah, there's more failure there. So our MTBF test was with PV cell, right? So I don't have any figures on, you know, failure rate with thermal energy harvesting. Our MTBF is with, but yeah, definitely, you know, if you have a lot of heat, you're gonna get, you know, more, you know, failure on product and stuff.
Do you have also information on the form factors for this board?
Yeah. I can. Let me try to. Let me see. I can send it right now onto the chat group so that people can. Let me send it right now. So let's see. That way people can get it.
Right. And you mentioned that your IoT is blockchain based and also security enabled. So that's the big, in sensor world, the security is critical, especially now in medical fields, right? It's been a big talk. Yeah. And so what kind of blockchain are you using and what kind of security you are using?
I can't.
I guess encryption.
Yeah, I would not be the best person to talk about the blockchain. I can, if you want, I can send my partner to do that, because that's
no, it's just so you're using like a SHA-256 encryption.
I'm not sure so much exact details about the blockchain, but I'll find out which one we're using first.
Okay, wonderful, thank you.
Okay.
It's just interesting. The implementation where you combine the IoT and blockchain is quite hot topic lately in the industry, so it's very popular. Okay,
so I sent a link just now onto the chat. So that's one of our disties that sells the reference design and there over there you can get, you know, the AT command set and a link to the SDK as well there too. So and then here's the reference design, the modules as well.
Okay, any other questions, guys? this is actually a very hot topic. You have a battery, green energy, IoT devices. The link to Zoom will be later when we finish a presentation. So once we close out the recording, the Zoom will send out the link and I will share it.
Okay.
And if you're talking about teamparagon.net, this is Brian. Can you open this teamparagon.net on your screen, because you are right now displaying?
Okay, sure. Yeah, let me see here. See here. Let me go back and screen share to my web browser. Do you see my share with my web?
Yes.
Web browser?
Thank you.
Yeah, so this is one of our distributors in Asia. I also have another distributor for Europe market, and so here you could show the data sheets, AT command sets, the actual product. So we sell, module and a. This is the large demo board, which has the module as well. I think if you want the PV cell one, just reach out to me, and we haven't posted the PV cell reference design on the website, but we can also provide that. Just send me an email and I can provide.
Thank you. This is good. Any other questions? And Daniel, thank you for your comment. I agree. Shri is asking, I have a series of deep dive on technology failure to markets and sales models. I'm not sure what that means, but okay. So let me ask you a couple more questions. On the sensors, if you go and on the sensors which you presented in the medical, how do you control the thermal, and how do you monitor that it's within the parameters and requirements of a specific medical device? So basically, because there is a very strict restrictions and specs on the medical devices which you have to meet in different conditions. And there is also, because the temperatures can slow down or speed up devices, and it's a life-threatening situations. It's very important. So how do you control that?
Correct. Yeah. So I mean, I guess there's two applications. One, we do like one of them is actually a image sensor. So it has actually, this image sensor is ingested, right? And then it connects via Bluetooth, basically through the intestines, right? So we do that right now with our other partner, OmniVision, right? So there is its own FDA, requirement. Anything that goes into the body. The air pump is a little bit, not as, it doesn't go inside the body, so there's not as much restriction, as tough of a, I guess, the FDA class 1 only, right? So I think, yeah, there's just, this is the, each his own requirement has his own, medical, requirements and stuff like that. So yeah, we each one has to be, each one has his own, has to have its own, I guess, requirements. So I don't know if I, answer your question, or Olga, what was your question, I guess?
Well, Shri is asking, could your devices be amenable to high temperature environment failure rate problems? So my thing is that in temperature affects the speed of the processors, and temperature affects a lot of other characteristics of the IoT devices. So in a life-threatening, how do you do the control of the temperature, and what are the ranges for these devices? Because if we start implementing it and integrating, what would happen? And Shri is asking, are your devices MIL standard qualified?
Yeah,
military standard?
They're not military standards. So we have two. This one here is a consumer temp, right? And then also have a extended industrial temperature. I think minus 40 to 85, right? But for medical, sometimes you have like a life. It's more on the in terms of lifetime, guarantee, right? But no military standard for this one.
Yeah. Another question: what do you have on these devices? Like, what do you have? A USB, Bluetooth? What else in terms of connectivity? What size of memory?
Yeah. So there's So I can share. Let me see if I can share the block diagram.
Let's go over it a little bit.
Yeah, I didn't know people would be interested in this, but let me go and share the block. Let's see here.
Yeah, can you zoom in?
There's no USB, right? So, but
Yeah,
SPI.
you have SPI, I2C.
Yeah.
You have PinMax, RF, link controller, and memory, right? That's a DDR2 or DDR1?
This is for our. I only have our M2 here, right? So we have another one with USB, but it's still not released yet, actually. So these are the the IOs currently here. UM, UART, general purpose IOs and stuff. So this is
right. And flash memory. Okay. Okay. So, is your pricing market based or cost plus? That's Shree's question.
Pricing market based.
So are you market competitive or are you having an add-on?
Oh, let's just say it's a very competitive. This is a, Bluetooth is a very, I guess, especially consumer Bluetooth, it's a very cost conscious, right? So these are all, I mean, you can see, how much we're selling it for, right? So I'm not really showing you the cost.
Okay, so no cost plus. Okay. Yeah. So any other questions, guys? I think this is very interesting. Actually, I'm excited to learn more about it. And DevKit is definitely option.
Yeah, I'll put my my contact, and then probably there's some more questions here. Pricing, competitive matrix and stuff. So I can do something, probably not here, but if you want something, how this compares to, the dialogues, the Nordics, NXP parts, we can do something there.
Bryan, everyone is asking for your email address. Can you
okay, let me write it down.
Just type it in on a Word document or on Notepad and display it on the screen.
Do you guys see it now?
Yeah.
Okay. Yeah.
No, if you display it only to hosts and panelists, so you need to display it to all.
Oh, everyone. Okay.
Yeah. Can you type it on a screen and just show it on the screen?
Okay. Yeah, I'll just do that. Let's see here.
Just
I got it. I got it to everybody now. I've also sent it to everybody. But let me send it to the Let's see here. Just do it as a
Notepad, anything?
Okay. Let's see here. I also put some information on the Word file, my email, my disty's website, and then my own company website. So
Thank you. Any other questions, guys? You can unmute yourself and ask questions if you have any. Sri is asking, are your devices good for inside human and animal bodies?
I would say the reference design, I would say is not ready for that yet. So once we we do have some application where we're going to have it intravenous, right? But there's a lot of requirements, it has to go through it, a lot of FDA certification first before we do that. So with a special enclosure and requirements. So I would say the reference design is not right now, it's not good for inside our bodies.
Okay, guys, I would like to start closing out today's session. Bryan, thank you very much for coming today and talking to us. And it's been a pleasure. I learned a lot and I want to learn even more. So on that note, I'd like to close today's, and the Zoom link, if anyone is interested, please send an email directly. Otherwise, it will be the recording will be displayed on our website, plus Bryan will share his slides.
Yeah.
Thank you very much, everyone, and have a nice, wonderful rest and the weekend.
All right, thank you so much. All right, bye.